Okay, so let's see. Yesterday we finished off with parallel circuits. Yes? Yes, we did. And so then I promised you that I would give you a little quiz.
Yesterday.
That was yesterday?
Yesterday.
You don't want it?
I do.
Okay. A take-home quiz? I don't think so. So we'll pause and do this. Okay. So we've done series. We've done parallel. Now it's time to bring on the hurt. What?
Not like that.
The only easy day was yesterday. Are you picking lice out of her hair, or what's
No,
it?
getting her glasses out of her hair. Monkey.
My goodness.
Rice is later.
All right, so series parallel circuits. They are both series and they are both parallel. Circuits. And in some ways, I guess this makes the most sense because we talked about how airplanes, cars, homes, everything's wired in parallel, but you can still have something in series with something else. So it kind of becomes useful. But let's just talk about it here because you do have to figure it out. Now, I will tell you, as far as I know, all of the FAA tests, they don't quite go into the depth that I will go into. Seems to me that they only need you to do calculate the total resistance. They don't ask you to calculate everything, but we're going to do everything just because we're better. All right, so here we have a series parallel circuit. And you should be able to see that, we'll label them, R1 is in series with R2. R1 and 2 are in series with R3, R4, but R3, R4 is a parallel circuit. Did everybody follow that? R1 is in series with 2. These two are actually in series with 3 and 4, but 3 and 4 are parallel to each other. And if I were to do this, I am going to. We'll do E, I, and R here. E, I, R there. E, I, and R there. E, I, R there. E, I, R there. It's a little hard to do here on the smaller screen. I usually use both boards so we can see everything at once and it makes more sense, but can't put that on YouTube's. Yeah.
So you said R1 and R2 are in series?
Series.
3 and 4 parallel?
Yep, 3 and 4 are parallel. 1 and 2 are in series, but 1 and 2 are in series with the group 3 and 4, and I'll show you that. So I'm going to throw down some numbers here. So 24 volts, 0.25 ohms, 2 ohms, 3 ohms, and 1 ohm. All right, so to solve something like this, you have to make it into either a series circuit or a parallel circuit. You can't leave it as a series parallel. And because looking at this, and most of them, it makes most sense to make it into a series circuit. And this one certainly does. So what I would simply do is rewrite this. I'll go back to black here. Rewrite it. So here's my R1. Here's my R2. And now I'm just going to make this R3, 4. R3, comma 4. So this is R2 and R1. And I'm going to solve it for this, which is something that you can easily do by now. So we have E, I, and R. E, I, R. E, I, R. E, I, and R. So we can just bring down what it is. We know that this is still 0.25 ohms. This is still 2 ohms. But what is R3, 4? What is it combined?
It's 1 over
Okay.
R1, 1 over R2.
it's a parallel circuit. So we're just going to solve for this parallel circuit right here, all by itself, almost as if I was looking at it, you know, it looks like this, right? There's my the picture of that, and that's going off. We'll just kind of make it almost like we're doing it like this. And saying, well, what is the E, I, and R total of this circuit right here? So we can start by, well, what is our total for 3 and 4? Oh, I did not bring my calculator. And since you guys aren't very loud.
7.5.
And it looks like what's happening is I have most of the class is not listening to me. They're just like, I'll solve it and it'll be done. Then I can just like put my earplugs in. And some of you are really paying attention, but you're too shy to say anything. So what is R 3 and 4?
0.75.
0.75. Well, is that correct? What is my check?
Add 'em all
3x1
together.
plus 1x1.
Right, but he said 0.75. How do I know that fast if he's probably right or probably wrong?
It's lower than the
Less than the smallest resistor, so I'm going to assume it's right. 0.75 ohms. Okay, 0.75 ohms. So, and this was 24 volts. 24 volts. Can I solve this down here?
Yes.
So what do we got? 3 ohms?
Yep.
And so that makes this 8 amps.
Yep.
Okay, 8 amps. 8 amps. 8 amps. 8 amps. Now I'll solve for my E. Put this over here. E, I, and R. So E is I times R. 2 volts. 8 times 2.
Oh,
16 volts. 8 times 0.75.
16.
6 volts. Okay, so I've got this. Now, these numbers just move up right here. So the totals are going to move up. They haven't changed. So that's 8 amps and 3 ohms. These will move up because R1 hasn't changed. 2 volts, 8 amps. R2 has not changed. 16 volts, 8 amps. But now I take this right here, and this becomes my total going into this right here. Just like I was bringing it up here. Just like I was solving it right there, and this was the total. So if, and I'll roll it down just a little bit, if I can. And we'll do that. So if I had two resistors in parallel, and what do I know about them? Let's see. E, I, and R. E, I, and R. I guess I don't need to be in a hurry. I know that my total is right there. 6 volts, 8 amps, 0.75 ohms. And I know that it's a 3 ohm resistor. That has not changed. 3 ohms. And I know that's a 1 ohm resistor. Everybody know where I'm getting all this stuff from? So if I know all that, now I just solve for what's down here on the bottom. So what is the voltage across these two? 6 volts. What is the voltage across this? Okay, what is my amps?
It's gonna be 8 amps, or sorry, 6 amps on
About 2. 3 times 2 is 6. 1 times
6.
6 is 6. Let's check it. So 6 plus 2 equals 8, because remember, the current is going to come down and go this way and that way. So if 2 go this way, remainder's got to go this way, 6. We already verified the resistance is 0.75, so these numbers just go back up here. 6, 2, and 3. 6, 2, and 3. And these go over here. 6, 6, and 1. Now let's take a look what we have over here. See if this makes sense. So here we have this circuit, and we start out here with 24 volts. So 24 volts are going this way, and 8 amps are going this way. So 24 volts, 8 amps. Come across resistor 1, and we lose 2 volts. What's left?
22.
22. All right, we have 22 volts. And how many amps do we have? Okay, how many amps do we have left after R1? 8. Okay, we go through 2, and I'm sorry, we had, what did I say, 20, 24, 22. Okay, we have 22, and we're going to lose 16. We lose 16, and how many amps do we have left? 8. So we still have 8 amps going this way, and we're down to, what did I say, 6 volts. So we come down here, well, guess what? 6 volts, 6 volts. We have 8 amps coming through here. We have 2 go this way, and 6 go that way. And they come back around, have 6 over here. So the 6 joins the 2, and now we're back to 8 amps going this way, and we've dropped all of the voltage going through. Or you can run it backwards and say you drop 6 volts, and what's left, 16, drop 2, and you're done. All right, so that's just all there is to it. And the only thing you can do from there is make them more complicated. But otherwise, that's exactly how you're going to do a series parallel circuit. Would you like to do another one?
Yes.
Unfortunately, yes. All right. Which means then I have to have some examples that actually work out. Okay. What did I just have? That's close enough. Okay. So, do the same thing where we got one here, one here, one there. Sometimes if you draw them differently, it makes a lot more sense. Like, I'll draw this one this way, and I think that would make more sense. So this would be R1, R2, R3, and R4. And let me see. I will give you 24 volts, 0.5 ohms, 4 ohms, 6 ohms, and 2 ohms. There we go. And I'll kind of quietly work it over here, and you just look up when you're done. I guess. May regret that decision. How'd you guys do? Ready for another one?
Yes.
Who's still working? Let's change it up a little bit. Who's still working? Let's see. Anybody need help?
I was like, oh, are we gonna go over these? But then I realized.
I just,
Yeah, for sure.
yeah. So I'm asking if anybody needs help because you guys did them so quick. Yes.
Can you show how to get the total resistance?
Sure. Okay. So I have this circuit right here, right? This is what we're doing. I have to redraw it in either a completely parallel or a completely series circuit. So I redrew it right here. R1, R2, R3, 4. All right? With me so far? So R1 is given at 0.5 of an ohm. R2 is given at 4 ohms. R3 and 4 I have to come up with. And because they are in parallel, it's 6 1 over x plus 2 1 over x equals some number, and hit the 1 over x key, and that's your number. Or x minus 1, however you go. And so that number became 1.5. So 1.5, because it's now in series, Kirchhoff said you just add them up. 1.5 plus 4 plus half is 6. Okay, next one. And if you need me to scroll back because you're working on that one, just let me know. So, all right, so this one will look like this. There you go. So we'll run it with 24 volts, 12 ohms, 6 ohms, 6 ohms, 6 ohms, 6 ohms, and 4 ohms, because you can't have that many sixes. So there we go. Yes. How you guys doing?
Are you considering 3 as parallel?
R3?
Uh-huh.
It's in series with 6 and with 4 and 5. So 12 ohms here. You have 6 ohms. Oops. 6 ohms here. You have 6 right here. And 6 and 6 together are going to make 3. Which is going to, and this is going to be 4. So when you combine all those, 12 is by itself, 6 is by itself, 6 plus 3 is 9, and 4 is, oops, that's not right.
Yeah, I was like, I get it.
Sorry.
That's what I was just.
And 4 is there, so you can, oops. So bring those together, 12, 6, 9, and 4. It's got to be less than 4.
I got
I got
1.63.
1.63.
I did too. It's right there on my calculator. So 1.63 ohms. Okay. It's very difficult to do on a small piece of paper. Use the whole board. Let's try it. So 24, and we came up with 1.63. So how many amps do we have? How many? That's what I got. 14.67. I got. Let me see.
14.72.
I got 24 divided by 1.63. 1.63 equals 14.7. That was called 14.7. 14.7. Okay. I was trying to do a shortcut. Normally I'll actually fill out all of this down here for each one. So that would be 14.7, just it gets really crowded. Then this is 12 ohms, 12, 6, 4. So then it's 24 here, 24 there, 24 there, and 24 there. But I can fill it in out here because R1 hasn't changed, so that's 24. R2 hasn't changed, so that's 24 volts. R3, 4, and 5, that's still kind of an undetermined right there. And R4 has, or this one over here, 6 hasn't changed, so that's 24. So I can kind of fill in some of this here. So it says 2 amps, 4 amps, and 6 amps. All right. You with me there?
Why wouldn't 3 have the same?
Okay. So now we get into 3 over here. Let's get some more going down here. So when we filled this in right here, even though it's kind of sloppy, this is 1, 2. This one right here is the 3, 4, 5, 6, 3, 4, and 5. So that's where we got to be looking at right there. So 3, 4, and 5 on this right here. Sorry, it's so small and kind of sloppy. So that's 24, 9 ohms. So what is my current flow?
2.6.
It's 24 volts, 2.67 amps, and 9 ohms. Okay. Now that has to work its way into this circuit. All right. And what do we know about series circuits? What stays the same?
Current.
Okay. So this right here is my total going into this circuit right here. So, do I have it right? Yeah. Okay. So what is the current flow? So we have EIR of one, EIR of my other one. This may not work out just because it's so small. I need more room to write. So what is the current going through these two? 2.67. Can you guys see this okay? And is it not? Is it confusing you? Okay. Sorry if you're watching on YouTube, because this is going to go the way I want it to go now. I am going to do this and do this, because this is the way I prefer to teach it. Hang on. Because this is really not too confusing. Oh, and I forgot, you guys can't see green as well as you can see black. This is not
I had it until that last one.
I got all the parallels.
Okay. So check it out. Here we go. Okay, so here's our circuit, right? We got. Everybody can see this okay?
Yeah.
Okay, so this is R1, R2, let's do that, R1, R2, R3, R4, R5, R6. But you should be able to get this. This is not, I'll put the total here. All right, EI and R. Honestly, the secret to doing this is lots and lots of paper. and lots of room. So givens were 24 volts.
12.
Thank you.
12 for 1, 6 for 2, 6 for 3, 6 for 4, 6 for 5, and 4 for 6.
Okay, so now I'm going to redraw this. I have to simplify it. Okay, so let's simplify it here. And so I have a resistor. Okay, that's R3. This is R4,
4, 5.
5, and this is R6. Got it? Okay. And we still have our totals over here. So, we take a look at what we have here. This one is still 12, but we also know that this is 24 volts, right? So what does that make it here?
24.
24 volts. What does it make it here? 24 volts with how many ohms? 6. Okay. Across here, it's a total of 24, right? But we'll get to that. This one here is 24 volts, right? And how many? 4 ohms. Okay, so we don't know what this is yet, right? We're still kind of lost on that one, so we got to do one more. So we go, this over here is going to equal that. R1, R2, R3, let's see, R1, R2, R3,
3, 4, 5.
4, 5, and R6. Okay, so this equals that. Can you get what we do over there? So this is what I just did over there. R1, R2, R3, 4, 5, R6. Yeah? Okay, so this right here I just did there, just duplicate. So again, what do I know? So I can't see the board anymore. So my total, just tell me right here. So 24, right? My total is still 24 volts. And this one is 24 volts and how many? 12 ohms. Okay, R2,
24 volts.
24 volts and how many? 6 ohms. This is R3, 4, 5,
24 volts.
24 volts.
And I believe
9.
9. Okay, where did I get to 9? Where did I get to 24?
So you would.
You define 4, 5.
Okay, this one is
6 plus the inverse of 6, and the inverse of that would give you 3, and you have 6 ohms with resistor 3, so you add those together.
Okay, so this one is 6 ohms because I just brought it down here. Now, what are these two are going to make up this one, 4, 5?
3 ohms.
So it's 3 ohms. Now, if I was really cool, I would have taught you a whole other formula that is, when resistors are the same, you just add them up and divide. So, but 6 1 over x plus 6 1 over x equals some number. 1 over x is going to equal
3 ohms.
3 ohms. Okay. So I got 3 ohms and I got 6 ohms. Well, how do I figure out the total of these two?
You add them
It's a
since
series.
They're in series, so you
Add them.
add them together. So the total is what? 9 ohms. And this one is 24 volts and 4?
4 ohms.
4 ohms. Cool. Now I just can figure out all the current flow, right? Current flow here.
2 amps.
Current flow.
4 amps.
Current flow. 2.67.
Yeah, 2.67.
Current flow here.
6.
Okay. So what is my total resistance?
1.63.
1.63 ohms. Why? Because 1 over x, 1 over x, 1 over x. Okay. And that gives me an amperage of
14.6.
14.6. And I can do that by adding it up. 2 plus 4 is 8, plus 6 plus 2.67. Does everybody agree with that? Okay, so cool. The hard part's done, pretty much. Now I just go backwards. Now I've got all the way down to here, which is as simple as I can. Just go back this way. So I go back over here and I say R6. Do I have R6 there by itself?
Yes.
I do. It's 24, 6, and 4. 24, 6, and 4. Cool. All right. We'll come back to this one. No, let's just do it now. So these I have to figure out. E, I, and R. E, I, and R. I can do it over here. So this one, just so you guys can see it, this one breaks down into, can you see that okay?
Yes.
Okay. It's 2 resistors over there, right?
Yep, yep.
Okay, so I just have to figure it out, and it looks like this. Green's hard to see, I forget. Okay,
But
so
isn't there 3 resistors
Yeah.
in that spot?
not yet. I'm working backwards.
Oh.
Here's my next one right here. There's only 2, right? So this one is going to go, this comes right over here. 24 volts, 2.67 amps, and 9 ohms. Okay, what does that look like here?
Series.
This particular one happens to be
6
R3, right?
Yes, R3.
And this is R4, comma 5.
Yep.
Okay, so come over here. What is my I?
2.67.
Okay, 2.67. What is it here? And we know R3 already because it's a given,
6 ohms.
6 ohms. And I know R4/5 resistance is 3. So what is my voltage drop across those? Hannah.
It is, for 3, it's 16.2, and, for 5, it's 7.8.
7.8. Okay, cool. So I got that. R3 is just R3. So I come over here and go, well, R3, I know R3. I can fill it in here. I don't need to. I can just plug it in here. What is it again?
16.2.
02. I got 02.
Okay, 0.2.
Whatever.
And the current?
2.67.
2.67. And it's 6 still?
Yeah.
Sweet. Okay. Because this is just a duplicate over there, so I'm going to get confused. Okay, and I know our 6 over there, 24, 6, and 4, right? 24, 6, and 4. That was easy enough. That's done. This is 24. I can see it right there. This is 24. Because I can know 24 goes through there, 24 goes through there. Then I know this is 2.
16.2 plus 7.8.
And this is
yeah.
4. Okay, everybody saw where I got all of that, right? Everybody's good?
Yeah. Yes.
Okay, you're not?
He's,
He's confused?
he's,
But he's gonna ask you, so?
he thinks that he thinks that 7.8 is wrong.
7.8, where?
He thinks
For the
that
resistance,
for the,
or
for
for
the
the
voltage
voltage
of
resistor
our resistant 4.5, it's 7.8, and the reason it is because when you add it to 16.2, it comes out to 24 volts. Yeah.
There you go. And also, if this is 6 ohms, and that's 2.67, that has to be 2.67.
But
So,
that doing 3 times 2.67 does not equate 7.8.
16.02.
what does this equal then?
It's, well, it's gotta be 16.02. It's not 16.2.
Oh, we do that. Sorry, somebody already told me that, and I put 1602 over here. But you were busy talking about something else.
Yeah.
I think so. Okay. 1602, 16.2. Call it 16. All right. Let's don't get hung up on the wrong part of this. All right. So you see how we just worked our way backwards, and now what we're left with is we've got everything filled out. And we know this from over there. What is it? 24. What is total?
Oh,
14.6.
2.67 amps.
Where are you even?
What?
At the bottom down here.
No, no.
41.6.
Oh, at the very top. Okay.
This is total.
Oh yeah.
14.6. 14.6. And how many?
1.63 ohms.
1.63 ohms. Okay, that is total. I mean, that's it. So now all we have to do is finish this one. And this one I can just draw over here real quick. Is
Holy shit. Are we having one question like this on the test, right?
We're only having
I need a piece of paper the size of my desk, please.
yeah, I've got another one I'll talk on in a minute, but we'll go on break in a second.
You have another desk?
But that's just what I do. I just use multiple pieces of paper. So this right here is R4 and R5, right? Okay, right here.
Yeah.
So what is my total voltage across these two?
7.8.
Right there, 7.8. What is my current?
2.67. And 3 ohms.
Awesome. And I know R4, because it's just one number, R4 is 6 ohms, and I know that this one is 6 ohms. Well, that kind of makes life pretty easy.
And your
Um,
voltage is the same because it's parallel.
So voltage is the same because it's parallel. And what is my amps going to be? They're going to be very close to the same.
1.3.
Should be half of that. 1.3. So, boom, just bring it over. 1.3, 1.3, 7.8, 7.8. All right, now, hang on, I'll give you the good news.
We're not done?
Does that look like it's done?
Yeah.
No, it does.
Okay.
I was done when it was first started.
Yeah, Well, I'll give you the good news and we're going to break. The good news is the FAA tests do not ask you to compute voltage and resistance.
What?
I'm sorry, voltage and amperage. They will only ask you to compute resistance total.
Yeah.
Oh.
So if you can do this, you're way ahead of the FAA. And it's actually building those brain muscles to help you understand Ohm's law and work it in. If you kind of give up, don't. I mean, do it. Now, I do have, well, I'll let you go on break, and then I'll tell you what I have. So go ahead, go on break.
Count to like that and then just
Well, that way you'll come back. Otherwise, you won't come back.
come back.
And sorry for everybody watching on YouTube, because you saw almost none of that.